Welcome to another episode of Numbers in Medicine. Today we will be discussing biostatistics and more specifically, risk. The objectives of this lecture include to define and learn to quantify the following: odds ratio, relative risk reduction, absolute risk reduction, and number needed to treat. This is our 2x2 table from our last session, and there are 4 outcomes for any test in disease state: true positive, false negative, and true negative. We're going to change that 2x2 table just a little bit and instead compare exposure to disease. As opposed to test, now we're talking about exposure. And the reason that's important is because exposure ultimately leads to some sort of risk. So again, you can be exposed and have the disease, exposed but not have the disease, not exposed and have the disease, finally not exposed and not have the disease. Again, 4 major outcomes. Let's start with odds ratio. Odds ratio reflects the odds of having a certain exposure given a positive disease state compared to the odds of having a certain exposure given a negative disease state. It's often used in case control studies. Case control studies will compare 2 groups. One group, the cases, have the disease. The other group, the controls, do not. And we look to see whether or not each of those groups had a particular exposure. Mathematically, odds ratio equals A over C divided by B over D. So it's a ratio of 2 different odds. The first one is comparing those who have the disease and were exposed compared to those who have the disease but were not exposed. So essentially odds of disease given plus minus exposure. The second group is B over D. For those who do not have the disease, odds of having the exposure. And then we'll have the 2 as a ratio, hence the odds ratio. The greater the odds ratio, the more likely the diseased is to be found with the exposure. The easiest way to discuss odds ratio is through an example. Whenever you're given a question about odds ratio, it'll be in the context of some disease state, some have it and some don't, and seeing whether or not a particular exposure influenced that disease state. So let's make up some numbers for the odds ratio for smoking history given lung cancer. Let's assume we have 100 participants in this study. 50 have lung cancer and 50 do not. So 50 with lung cancer, those are our cases, and the 50 who do not, those are our controls. Of the 50 with lung cancer, 40 of them smoked. And of the 50 without lung cancer, 15 of them smoked. So let's fill out that 2x2 table. This is the one we're familiar with the blank numbers essentially. We have 50 positive patients with lung cancer. 40 of those smoked. And 10 of those did not smoke. Next, we have 50 patients without lung cancer. 15 of them smoked, and 35 of them did not smoke. So we finished filling out our 2x2 table. And we know that our odds ratio is the ratio of 2 different odds, the first being lung cancer depending on smoking history. So the odds here are 40 over 10 compared to the odds of no lung cancer given smoking history. And here the odds 15 over 35. And that turns out to be an odds ratio of 9.3. You should look at the actual studies that have somewhat similar odds ratio. Some are even higher than this. Long story short, don't smoke. Said another way, the odds ratio of someone with lung cancer having smoked compared to someone without lung cancer having smoked is 9.3. Next, let's discuss the relative risk. It reflects the risk of developing a disease given a certain exposure compared to the risk of not developing that disease given exposure. It's often used in cohort studies. I like to call cohort studies because it looks at who will develop the disease. It compares two groups, one with exposure and one without. Mathematically, the relative risk is A over A plus C over the quantity B over B plus D. A is those with an exposure who develop the disease. A plus C is essentially all the people who develop the disease. Compared to B, which is positive exposure but didn't develop the disease, over B plus D, all those who did not develop the disease. So this helps show the relative risk between the two. We can imagine that if the relative risk equals 1, it means that the exposure is unrelated to the disease. That says A over A plus C was the same as B over B plus D. However, if the relative risk is less than 1, it means the exposure actually decreases the risk of disease. And if the relative risk is greater than 1, it means the exposure actually increased the risk of disease. A little caveat here, this assumes causality, but this trend generally holds. So let's do another example. What is the relative risk for developing COPD given smoking exposure? So it's looking at an exposure, looking ahead to see if they develop a particular disease. That's a classic cohort study. Who will develop the disease? So we have 50 smokers and 50 non-smokers that we follow for 20 years. Of the 50 smokers, 10 of them develop COPD, and of the 50 non-smokers, only 2 develop COPD. So back to our handy 2x2 table, we have smoking or the exposure on the left, and COPD or the disease state on the top. We said of the 50 who smoked, 10 developed COPD, which means 40 did not, and of the 50 who did not smoke, 2 developed COPD and 48 did not. We've discussed the relative risk in the formula here, A over A plus C over B plus D, which is 10 over 12 divided by 40 over 88, and that's 1.8. Here the relative risk is greater than 1, so if we were to assume causality, it would be that smoking was a significant risk factor for developing COPD, but of course after this you do confidence intervals to truly determine significance, but that's a whole nother story. Simply said, the relative risk of developing COPD for smokers compared to non-smokers is 1.8. Again, comparing exposure to non-exposure for developing a disease state. Let's do one more example that finishes up the remaining terms. Let's say there's this new anti-malarial drug on the market. Let's make up some numbers. Say the risk of developing malaria on this new drug is only 1%. However, the risk of developing malaria on a placebo is 5%. The placebo here is, of course, the control. Calculate the relative risk reduction, absolute risk reduction, and number needed to treat. Relative risk reduction is the relative decrease in the risk of developing disease for a particular group with the intervention compared to just the control group. So let's take a closer look at what that means here. It means that if we had a particular control group, in this case the placebo, they have some event rate for developing the disease. Compared to the group with intervention, or the experimental group, that has their own risk of developing disease, in this case with the new anti-malarial drug. The relative risk reduction is the difference between those two event rates, those two risks, divided by the control event rate. So in this example, it's 0.05, 5%, minus 0.01, 1%, divided by the initial control event rate, 0.05. So the relative risk reduction is 0.8. It's also an interesting note that the relative risk reduction equals 1 minus the relative risk. See if you can derive that for yourself to understand why. A different, yet still important term is the absolute risk reduction. And as the name implies, it's the absolute decrease in risk of developing a disease for a particular group with the intervention compared to the control group. So mathematically, it's the control event rate minus the experimental event rate. It's the absolute difference between the two. In this case, it's 0.05 minus 0.01, which equals 0.04, meaning the intervention had an absolute risk reduction of 4%, or 0.04. The final term is the number needed to treat. It is the number of patients that need to have the intervention for one patient to benefit. It's equal to 1 over the absolute risk reduction, 1 over 0.04, which equals 25. That means if we treated 25 patients with our intervention, one patient would ultimately benefit when compared to the placebo. There's another way to think about this to understand the math behind it. We said that 5% of patients on a placebo develop malaria. That's 5 out of 100. We also said that 1% of patients on this new drug develop malaria, 1 out of 100. So that means the difference between the two is 4 out of every 100. That's the absolute risk reduction. It says that for every 100 patients we have, 4 more will get malaria on the placebo compared to the intervention. With a little bit of basic math, 100 over 4 is the same as 25 over 1. So it says that for every 25 patients we have, 1 more gets malaria on the placebo compared to the intervention. So that's actually the number needed to harm. And in this case, it says for every 25 patients, 1 less gets malaria on the intervention compared to the placebo. That's the number needed to treat. So if you think about it just generally, absolute risk reduction, number needed to treat, are very easy to intuitively understand. They're not difficult to calculate, but here's the math behind it. And that is biostatistics quantifying risk in a nutshell. Thanks.